Unless you profusely pour baby oil on your scalp, this video is not for you. Probably you're a fan of oil, so, go continue your stuff. But if you're not in that particular population, we're going to be talking about oily scalp from sebum issues and how we can possibly treat it, because oily scalps can cause issues with folliculitis and seborrheic dermatitis. It can cause inflammatory cascades, which can lead to hair shedding. So this video is going to be jam-packed with a bunch of information, so use the timestamps in the description or comments below, or wherever it may be if the UI changes. We're going to go over some very important studies, so yes, use those timestamps. You can skip around the video, take notes, come back to it later when you're chilling out and gooning. But anyway, let's get on with the video. Oily scalp, scalp dysbiosis, seborrheic dermatitis, folliculitis, and the lipid microhormone axis. All these words put together, but they're pretty important. You see, when you have a chronic issue where your scalp is producing too much sebum oil, in some people that represents an underlying problem. Because, yes, it makes sense. We produce oil out of our sebaceous glands. That's a normal process, but if it's just squirting oil all the time, that's probably not good. Especially if that sebum you're producing is causing fungal colonies or bacterial colonies to sprout up, that's emblematic of a problem. You can go on Reddit or other websites and people will tell you, well, you got to eat carnivore, bro. You got to eat this very special diet. And yes, diet is a factor, but there are some people who are just predisposed. And their issues could be more hormonal. It could be based in diet, or it could be some kind of infection that they got a while ago that keeps recurring over and over again. It could be due to microneedling abuse, right? That is leading to other sort of compounding issues with folliculitis and, a sebum environment that's very favorable. It could be due to having androgenetic alopecia, which we will touch later on, produces a very distinct sebum profile for people who are balding compared to people who are not balding. So the discussion is very nuanced, and when you see people talking about this on the internet, it typically comes about in a very shallow way. Their takes are very shallow. And this is where the concept of the microenvironment comes into play. You have sebum, sweat, hormones, diet, hair density, fungal organisms, bacterial organisms, barrier function, follicular plugging, inflammation, and immune signaling all interacting with each other. And sometimes it doesn't just produce a simple cosmetic issue. It can produce some pretty severe clinical problems depending on how severe any of those previous factors I stated are destabilized. It can potentially push into a lipid-rich environment, and if you have a defect of some kind, let's say with your PPARγ receptor, which we will touch on later on in the video, that could lead to more serious issues where your hair follicles are essentially targeted for destruction by your immune system. So human skin has a very complex microenvironment with species of microorganisms that break down into subspecies, each kind of doing its own thing. And all of these microorganisms are essentially competing with one another, which by consequence stabilizes the environment, this sort of competition of resources. And in some cases, the resource might be the sebum that your body's producing. Maybe it's rich in cholesterol or triglycerides that feed these microorganisms. So we're going to have a look at the fungus Malassezia, in this case Malassezia restricta, the subspecies of Malassezia, the bacterium Cutibacterium acnes, and the other bacterium Staphylococcus hominis, which is Hominis, and Staphylococcus aureus, which is Aureus. In the paper Yang et al. 2023, titled, quote, Transcriptional interplay between Malassezia restricta and Staphylococcus species coexisting in the skin environment, unquote, Malassezia and Staphylococcus are among the dominant genre of microorganisms in the human skin microbiome. So when researchers co-cultured, or essentially they took Malassezia restricta with Staphylococcus and they put it inside of a petri dish, both of these microorganisms changed their gene expression behavior. And this is very important for this discussion, because it shows that the scalp is not just a fungus plus oil kind of thing or a bacteria plus oil kind of thing. It's an active interkingdom ecosystem where fungi and bacteria can change each other's metabolism, biofilm behavior, and the enzymes they secrete. And with all of that going on, that can impact the pH environment of your skin. The most useful insight from Yang et al. Is that the Malassezia restricta is a lipid-dependent organism, because Malassezia species cannot synthesize fatty acids efficiently and need to acquire them from the environment. That immediately supports the idea that an oily scalp can become a favorable habitat for Malassezia. But the paper also adds another layer. When Malassezia restricta was co-cultured with Staphylococcus species, genes related to ribosomal proteins went up, while genes related to secretory espatrial proteases. But what the hell does that even mean? Well, it means that when Malassezia restricta was around Staphylococcus, it started acting a bit, differently. Maybe it was kind of shy. It seemed to put more energy into basic growth and survival machinery because ribosomal protein genes went up. Ribosomes are like the cell's protein-making factories. At the same time, it turned down some of its secreted enzyme weapons, especially the aspartyl proteases. Those enzymes can help Malassezia break down things in the skin environment, and this may contribute to irritation and inflammation on the human skin. So that's why you might get those itchy feelings, or what some people might describe as the DHT itch, as we will explore later on in the video. But what you're essentially seeing here is that the presence and patterns between these two microorganism species, along with their subspecies, can cause one to change their metabolism, and it may also alter another. But we need to find a way to kind of stabilize the metabolism inside this microenvironment. When we look at the behavior of the Staphylococcus, specifically the Staphylococcus aureus, the presence of the Malassezia restricta forced the bacterium to go into stress mode. The Staphylococcus subspecies bacterium began to increase its metabolism. It grew less efficiently, and it had a weaker biofilm formation. This is significant because biofilm is one of the ways bacteria can become harder to clear. It pretty much serves as a protective layer against the body's immune system that would otherwise destroy it, and even against other microorganisms. So if you read this paper closely, you can see that both are inhibiting each other, but in different ways. Staphylococcus bacterium, when they're around Malassezia, they can grow but less efficiently, and they're more likely to create a weaker biofilm, so they can't produce a strong defense against other bacterium and against your body's immune system. In other words, they're so inhibited that they have a weaker protective shield. But that makes perfect sense because the bacterium is trying to send out these enzymes to suppress Malassesia's ability to disrupt its protective biofilm shield. So the biofilm shield of that bacterium, Staphylococcus aureus, does not have to be as strong because it's already inhibiting Malassezia in one important aspect. But its growth rate is being inhibited too, because that weaker biofilm caused by the presence of Malassezia leaves it vulnerable or more likely to be taken out by other bacterium species or your body's immune system. So in other words here, there is a very complex relationship where there's a homeostasis of sorts in a perfect environment. However, when there is overgrowth of either one species or a subset of species versus the other, you have to address what is causing that overgrowth. And that can look different for different kind of conditions like folliculitis or seborrheic dermatitis. Common to both conditions is a sort of barrier disruption. The outer skin layer's protective barrier allows for even foreign bacterial colonies to come in and disrupt the whole process, which can push the fungal colonies to go in a direction where it's more likely to cause seborrheic dermatitis or more severe fungal overgrowth, or again, more kind of acne-like folliculitis appearances on the scalp. The key takeaway here is, if overgrowth does happen, how do we disrupt with the metabolism of these organisms to kind of put them back into a more homeostatic environment? And there are tools that dermatologists use in order to figure out what you're expressing more of, what you have a higher overgrowth of. The KOH wet test tool is when they go in and scrape some parts of your skin and then they send it to a lab, and then they allow it to simply grow in a petri dish, and there they can assess what the overgrowth is. And once you have the idea of that, you can understand what medications, whether topically or orally, one may use to disrupt with these fungal or bacterium colonies by disrupting with their metabolism. In some cases, they might even find viruses contributing to certain diseases. This imbalance of the communities of microorganisms, bacteria, fungi, viruses, on your body or even in your body is called dysbiosis. And while we're at it, this is where something like the gut-skin axis becomes relevant. According to Zhao et al. In their 2025 paper titled, quote, "The gut-skin axis, emerging insights in understanding and treating skin diseases through gut microbiome modulation," unquote, the gut microbiome can influence skin health through systemic immunity, inflammatory responses, and metabolic pathways. They also note that the diet is one of the major factors in shaping the gut microbiome, and that the gut dysbiosis has been linked to inflammatory skin diseases, including acne, in some cases psoriasis, and in some cases atopic dermatitis, and also weakly related to alopecia areata. It might be the case with alopecia areata, you could have some autoimmune conditions that disrupt the gut microbiome, which also correlate with autoimmune skin conditions that would mess up with the hair follicles in the alopecia areata case. But in a practical sense, this means that diet obviously influences the scalp indirectly by changing gut microbial metabolites, inflammation, and IGF-1 signaling. And remember, what you eat is what you secrete. So if you're eating tons of processed foods, tons of sugar, a diet high in cholesterol and fats, or if you're eating foods that you have an allergy to, these can contribute to you having issues on your skin. But it could be a very complex process, so you have to explore what your sensitivities are in your case. Because you'll have some people that will try to simplify this, where it's like it's only what you eat, but you can't just say, oh, just eat better, bro. In some people, oily scalps may be layered with issues involving their genetics, right? Some people have poor genetics where they can't break down lipids, so they just constantly release it through their skin. They have high cholesterol levels, genetically speaking. Maybe a PPARγ gamma receptor defect. Some people might have high androgen load by way of DHT. Maybe, their DHT is hyperactivating their sebaceous glands to the point where the sebaceous glands are just putting out tons of sebum, no matter what they do, even if they eat cleanly. We know that androgens do impact the sebaceous glands, specifically DHT. You also have medications that can disrupt the barrier function, so on and so forth. So my quick recommendation would be to start with a sort of low glycemic, high fiber, anti-inflammatory diet, reduce alcohol and obviously dairy and sugar triggers, and focus on consistency rather than pretending diet alone fixes every scalp problem. Just try to eat as healthy as you can. But that's for the gut and skin microbiome axis. Let's go back to the skin for a quick moment. I want to talk about medium-chain triglyceride oils and why the conversation around topical oil use sometimes can be a bit confusing. Because some oils might help with an oily scalp, while other oils may worsen it. Certain scalp conditions like seborrheic dermatitis can encourage for even more poor sebum production. And there are certain oils that can disrupt with the metabolism of overgrown fungal microbial colonies and bacterial colonies as well. These microbes need to break down lipids in order to survive. It's where their food is. So if you're giving it something that it can't break down properly, less of them can survive, which may revert them to a proper baseline. In the 2019 paper by Dobler et al. Titled, quote, "Impact of Selected Cosmetic Ingredients on Common Microorganism of Healthy Human Scalp," unquote, Malassezia species showed growth with many fatty acids, fatty acid esters, fatty alcohols, and oils, especially longer-chain lipid ingredients. But the authors found no Malassezia growth with fatty acid esters shorter than 12 carbons. That is, where C6 and C8 medium-chain triglyceride type lipids become interesting. C6 is caproic acid and C8 is caprylic acid. These shorter-chain lipids do not behave like long-chain plant oils that Malassezia may sometimes use more easily. Dobler et al. Also specifically mentioned that medium-chain fatty acids such as caproic acid, caprylic acid, and capric acid have broad antimicrobial activity. So the question is, how do they have antimicrobial activity? Looking at the 1999 paper by Papavasilis et al. Titled, quote, "Medium-chain triglycerides inhibit growth of Malassezia," unquote, the MCTs, the medium-chain triglyceride free fatty acids, were toxic for Malassezia species. The researchers found that MCTs suppressed Malassezia growth and that MCT free fatty acids could suppress some Malassezia species at even low concentrations. Specifically, I would stay around C6 and C8 MCT oil, and it may quell seborrheic dermatitis in some people, not because it's moisturizing or anything like that, but it's actually strangling and killing the overgrown microbial colonies by essentially presenting a hostile environment where they can't metabolize properly. And this is why it sounds weird and off, because you wouldn't expect more oil to cause for there to be less oil, but the presence of an overgrown fungal colony encourages the scalp to produce more sebum. So by getting rid of those microbial colonies with an oil that strangles them, essentially it's going to help reduce that overgrown fungal colony and bring the sebum production to a normal parameter. And a lot of people might have subclinical features of seborrheic dermatitis, where unless you're paying close attention, you probably won't see the sebderm fungal issues on the scalp, but it may present itself as dandruff, which really is sebderm. Likewise, the same thing is happening with Staphylococcus colonies when they come in contact with MCT oil. Corynebacterium et al. In the 2013 paper titled, quote, "Improvement of medium-chain fatty acid content and antimicrobial activity of coconut oil via solid-state fermentation using a Malaysian Geotrichum candidum," unquote, modifying coconut oil to increase free fatty medium-chain acids greatly improved its antimicrobial, specifically antibacterial, activity. Their optimized modified coconut oil contained about 53% medium-chain fatty acids. They looked specifically at C8, C10, and C12 in this study. Now, I know there are some people who say don't go up to C12, being lauric acid, but it should be fine in some cases, but typically the lower the MCT chain, the better. So I would just say stay between C6, maybe going all the way up to C10, C10 being capric acid, but I guess the range between C6 up to C12 should be fine for a broad amount of people. So guys, the takeaway in this section is topically, MCT oils can actually help you reduce seborrheic dermatitis and also in the long term, quell overgrown microbial colonies. And I know I've been asserting this throughout the video, but yes, these overgrown colonies of Malassezia and even some bacterium can encourage more sebum production. According to Cheng et al. In the 2025 review titled, quote, "Research Progress on the Exacerbation of Lipid Metabolism by Malassezia and Its Impact on the Skin Barrier Function," unquote, Malassezia can create a feedback loop where it uses scalp sebum as food, secrete lipases to break down triglycerides into free fatty acids and glycerol, and then leaves behind irritating fatty acids like oleic acid that can disrupt the barrier and stimulate inflammation. The review specifically says that Malassezia-derived free fatty acids can stimulate sebaceous glands to create more sebum, creating a sebum-overload fungal proliferation feedback loop. So yes, this paper is really, really good at showing that. But once again, it does not mean that Malassezia is the only reason why somebody produces more oil, specifically more sebum oil that supports this sort of microbial overgrowth. But it does point to why you don't want that overgrowth of Malassezia and even some bacterium as well, because it is happening with the bacteria. So now that we have an understanding of the microbial microenvironment, let's talk about hormones, because DHT and androgenetic alopecia has some pretty significant implications here when we're talking about oily scalps. A lot of people talk about this concept known as the DHT itch. And this is where perhaps more androgen-sensitive parts of the scalp, where typically you would see the hairline or the crown region thinning when it comes to the condition of male pattern or female pattern baldness. Some people talk about these areas being more itchy than other areas. They'd often say that I can tell when I'm about to shed my hair because I have this itching sensation. And that makes sense. Like I said before, Malassezia is going to produce free fatty acids by breaking down your skin, and that encourages your sebaceous glands to produce more oils that ultimately feed the Malassezia. And even the bacterium there are doing similar things too when they're overgrown. And just alone, this free fatty acid release is enough to disrupt with the hair follicle's hair growth cycle. I talk about this in another video where I go over weight loss and free fatty acids when it comes to hair shedding, so I'll leave that in the description below. But in any case, the DHT itch is not simply due to DHT itself, but it's due to the effects that DHT causes to the sebaceous glands, because DHT can hyperactivate sebaceous glands in the skin to force them to produce sebum that's rich in triglycerides and cholesterol, and we actually have a study that shows this being the case. In the 2021 Suzuki et al. Paper titled, quote, Scalp Microbiome and Sebum Composition in Japanese Male Individuals with and Without Androgenetic Alopecia, unquote, the authors analyzed the sebum on the scalp of 118 Japanese men with and without androgenetic alopecia, and they wanted to see the composition of bacterial and fungal microbiome differences between these two populations. This paper is very important because we're not looking at DHT from just the aspect of hair loss alone, but also what it's doing to our scalp and microbiome ecosystem. The authors found that the group of men with androgenetic alopecia had higher scalp triglyceride and palmitic acid content, more Malassezia restricta, and bacterial dysbiosis marked by increased Cutibacterium and decrease Corynebacterium. Once again, we get some more confirmation when it comes to the sebum composition, right? Suzuki et al. State that the fatty acids like palmitic acid and oleic acid can be generated by lipases produced by the Malassezia and Cutibacterium acnes. And these lipase compounds are going to encourage this itchy sort of feeling, that DHT itch. The androgenetic alopecia group also saw an increased Staphylococcus marker, but I think what's more important is assessing the group that did not have androgenetic alopecia, the non-balding group, and also the decrease of the Corynebacterium. Why did it decrease, and what does Corynebacterium in respects to Cutibacterium and even Staphylococcus bacterium, what is its importance? Is it a sort of regulator of sorts? Well, the presence of Corynebacterium will regulate Cutibacterium by simply consuming the nutrients, consuming the lipid pool. So by this competition, it can help limit the Cutibacterium overgrowth and also the Staphylococcus overgrowth. However, a key feature of some of the Corynebacterium species is that they lack a functional fatty acid synthase, meaning that they wholly rely on environmental or host-derived lipids to survive, whereas the Cutibacterium can break down triglycerides in the human skin to create those free fatty acids that it enjoys. Cutibacterium is also going to be at the deeper layers of the skin, so you have deep niche colonization. So Cutibacterium is anaerobic, meaning that it doesn't need oxygen to do its operations, but it's also aerotolerant. Most anaerobic bacteria, when they're in the presence of oxygen, they can't grow properly. But Cutibacterium, this is different. They can survive and thrive in the presence of oxygen even though they don't need oxygen to grow. It is not an essential energy source for this Cutibacterium. So you're going to find it deep in the follicle niche and in more oxygen-depleted layers of the skin. However, the Corynebacterium species prefer aerobic or microaerophilic conditions, so in conditions that have a tendency to favor oxygen. So this means they're going to thrive in more moist environments, but also they can't effectively compete deep in the sort of sealed and suffocating environments that have sebum blockage. So this could be skin pores, and this is where Cutibacterium reigns supreme. But they are present in the sebaceous glands. And because of this overproduction of DHT, it's pushing the sebum profile to favor triglycerides and cholesterol, which Corynebacterium cannot break down these lipids into free fatty acids, whereas Cutibacterium can, because it has that machinery, like we mentioned before. Now, once you have this environment that favors Cutibacteria, well, Cutibacteria, as Suzuki et al. Already notes, produces something called cutimycin, and cutimycin is an antimicrobial that can kill other microbial colonies, whether they're fungal or bacterial. This is why you're going to get this sort of runaway cascade of these things that mostly encourage for more oil to be produced. So we're adding more to the equation. DHT, which is going to increase sebum production, and these microbial colonies, which are going to provide a feedback loop to make your skin, your scalp, more oily. And I know it sounds like I'm repeating myself, but guys, I kind of have to because this microenvironment is very complicated. There's a lot of interplay and people don't give it a lot of credit. So if somebody's having like chronic oily scalp, it's probably because of this weird interplay between the microbial environment and also DHT. All these things can cause for hair shedding, microinflammation, so it's really important that we understand what's going on. And you guys can always look at the screen because there are notes during this presentation. By the way, I forgot to note that Dutasteride can reduce sebum DHT and scalp DHT by between 50 to 80% between 0.5 milligram up to 2.5 milligram, according to Olsen et al.'s study on this particular drug. So it does have some potential benefits when it comes to treating an oily scalp and even potentially improving acne parameters. An anti-oily scalp protocol needs to target several parts of this feedback loop at once. You need to reduce the lipid fuel that's encouraging for microbial overgrowth. You need to control for Malassezia. You need to reduce the Cutibacterium-driven follicular inflammation if bumps or pustules are present. You need to account for Staphylococcus and biofilm behavior when folliculitis is present. You need to avoid destroying your skin barrier. This is important. If that skin barrier is disrupted, then you're going to have other issues from the external environment. More odd-like bacterial infections. You need to reduce internal sebum triggers like high glycemic diet patterns, dairy sensitivities if you have it, any sort of alcohol or excessive alcohol consumption, and also foods that you're generally allergic to. Because if you're allergic to foods and it causes hives and all those sort of issues, your skin probably wants to expel whatever allergen that is out of your body. That's also another pathway. Plus, just general inflammatory issues from that allergen can cause your skin to overreact and just give you more issues overall, harming the skin barrier being one of them. But also there's another thing that I mentioned in this video, and that is the PPARγ receptor. This also belongs in the conversation. PPARγ, or peroxisome proliferator activated receptor gamma, and this is a receptor part of a group of cell-bound intracellular nuclear receptors that act as transcription factors to regulate gene expression, particularly when it comes to lipid profile. When these receptors are activated by specific lipid-derived molecules, which are called ligands, they bind to specific parts of the DNA inside specific cells, and they will activate specific genes. So in this case, if you're looking at your sebocytes, for example, your sebocytes are part of your sebaceous glands. They help produce sebum. If you have a lipid that can connect to this receptor, and the receptor is like a keyhole, if it can connect perfectly or sufficiently to that receptor, it can create this complex, and that complex can go into the area of your cell called the nucleus, which houses your DNA. When this complex interacts with your DNA, it'll fit to certain areas of the DNA that are responsive to the complex, and it will activate certain genes. So it's kind of like going into this huge book of certain instructions, and it's picking out specific instructions to build a certain molecule or to do a specific process. Now, I mentioned PPARγ, which is what we're going to focus on, but there are other PPARs like PPAR-alpha and PPAR-beta and delta. PPAR-alpha is primarily found in the liver, heart, and skeletal muscles, and it regulates the breakdown of fats and energy expenditure. PPAR-beta and delta, these are ubiquitously throughout your body, and it's heavily involved in just burning fatty acids and regulating general energy expenditure as well. There are some drugs that work on PPAR-beta and delta, this particular pathway, and you probably heard of one. It's an experimental one called Cardurine, or GW501516, and it can simulate fat burning by binding to that PPAR-delta receptor and pushing it to kind of hyperactivate fat oxidation. It also does something interesting that I'll kind of note quickly because it's kind of off topic, but I think it's worth noting. But it increases the production of type 1 slow twitch muscle fibers, which are highly oxidative and resistant to fatigue. So some people in long distance events, they dope up on this particular drug, which is, pretty bad. It's cheating, and it can give them an unfair advantage. But research has shown it can improve blood lipid profiles by increasing HDL, and that's the good cholesterol, and lowering triglycerides. It's kind of a shame that this drug never made it to market due to some, just stupid cancer scares that was mostly observed in rodents. And those rodents were dead, and they were, I'm pretty sure, genetically modified to have cancer, or in this case, bladder cancer issues already. Not only that, but they exposed those cells to ridiculously large quantities of cardarine, and that was the moment they saw some signs of a sort of cancer forming. But that was just such an extreme sort of experimentation that it very much likely doesn't go one-to-one in humans. So it's a real shame that this drug that was probably the Ozempic before Ozempic was Ozempic, that this drug never made it to market. In my opinion, out of all the experimental drugs, not telling you to use anything, by the way, but this one looks pretty good. But I digress. Focusing back on the PPARγ receptor, it's concentrated in adipose tissue, being fat cells and immune cells. But it's also in and around the hair follicle environment, the pileosebaceous unit, as it's called. If you have an underactive PPARγ receptor, this means that you're going to have a lipid-rich environment. And when there's too much lipids in an environment that can't properly regulate those lipids, you're not only going to get a microbial overgrowth of some kind, whether it's chronic seborrheic dermatitis, a sort of weird acne of the scalp, damn near folliculitis in some cases, but there is some connection to autoimmune conditions, specifically scarring or cicatricial alopecias like lichen planopilaris, also known as LPP, along with its related conditions like frontal fibrosing alopecia or fibrosing alopecia in a distributed pattern. And this issue is not just too much oil or too much fungus, it literally involves deeper lipid handling disorders around the pileosebaceous unit. Again, if this lipid metabolism is dysregulated, excessive lipids become toxic and inflammatory, and this can lead to your body trying to get rid of whatever is chronically producing those lipids. If your sebaceous gland is just squirting out all this lipid and it's becoming dysfunctional, well, your immune cells, your lymphocytes, are going to infiltrate the area and try to kill or inhibit whatever's causing this problem. And this huge inflammatory cascade can build up around the hair follicle and damage the stem cell niche. Now, forgive me because I'm going to get a bit opinionated here. I do think there possibly is some kind of use case when it comes to PPARγ agonist topically, specifically when it comes to acne and even in these sort of weird oily scalp conditions, because there is an argument to be made that if you can increase the local metabolism of lipids, then you can probably help a lot of conditions. So there are drugs like pioglitazone hydrochloride, which I'm not telling you to use, go talk to your doctor, but orally and topically, they've been shown to ameliorate the condition of lichen planopilaris, but also in some cases help with acne and dermatological disorders. But they have their own side effects, which include weight gain if taken orally. But I'm going to introduce you to something that one of my friends and co-founders of one of my companies introduced to me, and this is the class of naturally occurring compounds called amorphutins. According to Fur et al. In the paper titled, quote, amorphutins are natural PPARγ agonists with potent anti-inflammatory properties, unquote. Amorphutins are natural PPARγ activators found in plants such as Amorpha fruticosa and Glycyrrhiza foetida. The paper also goes on to talk about how PPARγ activation can inhibit inflammatory gene expression through mechanisms involving NF-kappa beta and other inflammatory pathways. In that same Fur et al. Paper, amorphutin A, a specific type of amorphutin, reduce inflammatory markers of TNF-alpha simulation, including COX-2, GRO-alpha, interleukin-8, and MIP3-alpha. My interpretation here is not that amroflutins are proven oily scalp treatments. They're not. But mechanistically, they are very interesting. In fact, I don't think there are any topical amroflutins at all, and this will change. If oily scalp, seborrheic dermatitis, folliculitis, and some inflammatory alopecias involve lipid dysregulation plus immune activation, then a selective PPARγ modulation deserves way more attention than what it currently gets. And this is something my team and I are looking into at Folligens Therapeutics Corporation, which you can check our website, folligenz.com. That's folligens.com. We have our own pipeline over there, and yeah, we're trying to do some research into this. Hopefully we can get something that is promising. Another aspect in treating an oily scalp, or in general oily skin, is possibly just crushing the oil in the sebaceous glands altogether. And there are some drugs that can do this. I've already mentioned PPARγ activation, but also retinoids like tretinoin can do this. Look, if somebody has severe oil production where the scalp gets greasy again within hours of washing their hair, and they also have persistent itch, follicular irritation, acne-like bumps, and or seborrheic dermatitis that keeps coming back, then I would put sebum suppression in a separate escalation category. At that point, the goal is not to just kill the fungus or bacteria. The goal is to reduce the lipid-rich supply that keeps feeding the whole scalp microenvironment and the overgrowth aspects of it. According to Geisler and colleagues in the 2003 paper titled, quote, "Very low-dose isotretinoin is effective in controlling seborrhea," unquote, the author studied 11 patients with excessive seborrhea, coarse pored skin, minimal acne, and oily scalp hair. This is important because the study was not only about severe nodular acne, but it also included just people having other conditions, specifically our oily scalp concerns. The patients were treated for 6 months with very low-dose isotretinoin, 5 milligrams daily, 2.5 milligrams daily, or 2.5 milligrams 3 times a week. In Table 2, the authors show subjective seborrhea scores for face and scalp. The 5 milligram per day group had a facial seborrhea regression of about 70%, and the excessive scalp hair oiliness reduced by 49%. The 2.5 milligram per day group had a facial seborrhea regression of about 44%, and when it came to their excessive scalp hair oil, it reduced by 38%. 2.5 milligram 3 times a week. For that particular group, it showed smaller effects with about 27% facial seborrhea regression and about 30% regression of the excessive scalp oil. This is important because it suggests that there's a sort of dose-responsive pattern here, even with inside the microdosed range of isotretinoin. Now, Table 3 is also important because it shows sebum excretion rates changes over the 6-month period. The 5 milligram per day group went from a mean sebum excretion rate of what the authors score as 67 arbitrary units per square centimeter per hour at baseline to 33 by month 6. The 2.5 milligram per day group went from 143 at baseline to 52 by month 6. The 2.5 milligram 3 times a week group went from 105 at baseline to 43 by month 6. So even though the study was small and descriptive in some nature, the sebum output trend is very relevant to oily scalp management. The authors also found that sebum production reduced by up to 64% and acne lesions by up to 84%, follicular filaments by up to 60%, and more importantly, sebaceous gland size by up to 51%. It also reported a quantitative reduction in Corynebacterium, which, by the way, is another name for Cutibacterium acnes. They also note that it did this decrease of Cutibacterium without increasing Staphylococcus epidermis, so another species of Staphylococcus, which is pretty important because if we're not having an issue with the Staphylococcus species, then this could be a sort of selective target of possibly one of the most abundant bacteriums on our skin and inside of our skin, being Cutibacterium. And that bacterial finding matters because it ties back into the whole dysbiosis we were talking about earlier in the video. If very low dose isotretinoin reduces sebum and also reduces Cutibacterium, also known as Corynebacterium, without increasing Staphylococcus species, we're probably sitting on something that can be very targeted in terms of its treatment and can greatly reduce an oily scalp. Now, somebody might be asking, why the hell would we even want to microdose isotretinoin? Why not just take the whole dose? Well, this is because you can't take a full dose for an extended period of time without getting some pretty nasty side effects, and you don't want to permanently reduce your capacity for your glands to produce any kind of oil, because that can happen in more extreme conditions. Accutane, which is the brand name for isotretinoin, has a prescribing information booklet that describes the standard treatment in the range of 0.5 to 1 milligram per kilogram of body weight per day, usually taken in 2 divided doses for 15 to 20 weeks, and for severe scarring or trunk predominant cases of nodular acne, 2 milligram per kilogram of body weight per day. So this means that conventional and normal doses of Accutane or isotretinoin is calculated based on body weight. A person who weighs more generally receives a larger milligram dose than a person who weighs less. For, say, a 60 kilogram person, which is about 132 pounds, the standard 0.5 to 1 milligram per kilogram range equals to about 30 to 60 milligrams per day. A high dose 2 milligram per kilogram approach would equal about 120 milligrams per day for that same 60 kilogram or 132 pound person. For an average adult woman in the United States of America, the CDC, or the Center of Disease Control, reports a measured average weight of 171.8 pounds, which is about 77.9 kilograms, or roughly 78 kilograms. At that body weight, 0.5 milligram per kilogram per day would be about 39 milligrams per day, usually rounded clinically to something like 40 milligrams per day, depending on the product and prescriber. For the 1 milligram per kilogram of body weight per day, this would come to around 78 milligrams per day, often approximated at 80 milligrams per day. 2 milligram per kilogram of body weight would be around 156 milligrams per day, roughly around 160 milligrams per day. So those side effects are usually going to happen at those conventional or higher doses. We're just talking about what is pretty much a very, very, very low, a microdose, literally a microdose that never went near the kind of conventional doses that are typically used for more serious acne conditions. And even then, when you look at the biopsy that they did, I think it's in Table 7 in the Geisler-Seborrheic study, you can see at those microdoses you're getting a change in the sebaceous gland and the sebum parameters and so on and so forth. So you can expose yourself at a very low microdose range and still get benefits from it. And you can use this, potentially, go talk to your doctor, to improve an oily scalp. But still, isotretinoin has to be treated with respect because it's highly teratogenic, meaning it can cause severe birth defects, and it is approved only under restricted I-pledge terms. And this, I think, is mostly specific to the United States of America, but I'm assuming other major body health organizations around the world have their own requirements. The I-Pledge program is to mitigate embryo-fetal toxicity risks to isotretinoin. So this is mostly going to impact women who are taking this thing orally. But both men and women have to sign up. Women are going to become pregnant, so pregnancy prevention is actually important when it comes to taking isotretinoin. So you have to work with your prescriber, you have to, do frequent pregnancy testing, and even sometimes you have to be put on birth control if you're a woman listening to this. You don't want to expose your fetus to isotretinoin, right? Especially you don't want to be in the sort of dilemma where you're already pregnant and then, you've been taking this medication for, let's say, 2 months into your pregnancy. That's not a good thing. And, you might have to do the old abortion thing. So I'm not going to touch on that, but, I don't want to get too political. So let's move on to the next part of tretinoin use. So topical tretinoin and isotretinoin, they're the same drug. But when it comes to isotretinoin, especially at the more conventional and higher dose ranges, and when it comes to more prolonged use of those higher doses and conventional doses, temporary hair thinning and shedding has been noticed in the literature, and it's usually noted as a side effect on the isotretinoin packages that you get. Usually it's framed as telogen effluvium. When we look at the paper Litvin et al. In the 2022 systematic review titled, quote, comparing frequency of isotretinoin-induced hair loss at less than 0.5 milligram per kilogram per day versus greater than or equal to 0.5 milligram per kilogram per day dosing in acne patients, unquote, patients on less than 0.5 milligrams per kilogram per day had reported hair loss at a frequency of 3.2%, while patients on 0.5 milligram per kilogram of body weight per day or higher had reported hair loss or shedding at 5.7%. So it seems you can expect at conventional or even higher doses a 3 to 6% range where people will be complaining about shedding. And obviously that risk factor is going to be patient specific. So there are probably specific, traits about these patients that exist between a 3 to 6% frequency within this population. Again, this is for the typical and higher doses that we have to worry about. And it's not for the microdoses of isotretinoin. And because we also are talking about the scalp, I don't think people want to lose their hair while trying to mitigate oily scalps, right? Now, hair loss is a bit of an exaggeration because telogen effluvium is not hair loss. Those are two different things. Although sometimes authors try to call them the same thing, it's a bit of a mistake when they do so. Because actual hair loss involves the loss of hair follicles that can regenerate. When it comes to telogen effluvium, in most cases, the hair follicles have the ability to regenerate. Although in a purely telogen effluvium issue, where you don't have androgenetic alopecia, in those biopsies, the hair follicles are usually dormant, and that dormancy can last anywhere between 3 to a chronic 6 months. So, there is some cases, I guess you can call it hair loss, but in a more technical term, it's different. So we don't want to have a shedding of hair when using isotretinoin. And we can possibly prevent that from happening by going for a very low dose of it. Now, mechanistically speaking, there is an explanation as to why hair shedding occurs on isotretinoin, especially at the higher doses. According to Folliculitis et al. In 2005, in a paper titled, quote, Towards Dissecting the Pathogenesis of Retinoid-Induced Hair Loss, all trans-retinoic acid induces premature hair follicle regression, catagen, by upregulation of transforming growth factor beta-2 in the dermal papilla, unquote. Now, this was an ex vivo study where the authors were able to get 6 human anagen hair follicles, so hair follicles that were already in their growth states. They exposed them to all trans-retinoic acid, also known as tretinoin. Again, this is the same active ingredient in Accutane, and again, topical tretinoin. They found that the hair shaft elongation declined significantly after 2 days of exposure, and by day 6, about 80% of the tretinoin-treated hair follicles entered a catagen-like state compared to the 30% in the control who were not exposed. They also found increased apoptosis, reduced signals of cell proliferation by noticing the reduction of Ki67 protein, and increased TGF-beta2 signaling in the dermal papilla. The dermal papilla, as I've stated in many videos, is very important because it signals to the hair follicle stem cells when to grow and when to stop. It tells them to migrate out of the hair follicle stem cell niche and move into the lower architecture of the hair follicle unit. So if you're having your dermal papilla disrupted with, then it can't properly signal to the hair follicle to continue growing hair. So eventually it reverts and goes into a catagen-like state, which also leads to telogen, where the hair is getting ready to fall out, which would be the exogen phase. This is what we would typically call hair shedding. Now, again, this is on ex vivo hair follicles from humans, so it's not actually being monitored in a human being. But we can probably say the same thing is happening with isotretinoin when you take it orally at a conventional or even high dose for a prolonged period of time, because it's really just flooding your hair follicles and your skin with what is essentially going to reduce your dermopapilla signaling. So we kind of have to strike gold and hit a happy medium. And I think microdose isotretinoin is going to do that and help with an oily scalp while mitigating the hair shedding aspect of isotretinoin. But also, it means that for those of you who use tretinoin topically, especially at a chronic high dose, maybe anything at 0.1% every single day, you could be shortening the potential anagen phase of your hair follicles. I know it helps with absorption when it comes to minoxidil and the conversion of minoxidil into minoxidil sulfate, but you want to know what helps with that, right? Just getting plain old minoxidil sulfate, which you can get, I'm sorry, I got to plug, it's my company, of course I'm going to plug, which you can get from folligens.com, folligens.com. Minoxidil sulfate is there, but still, even then, you probably shouldn't be chronically using topical tretinoin every single day on your scalp. Maybe give it a break, maybe use a lower dose 2 times a week, 3 times a week. That could possibly help reduce this sort of stress, so just be careful. But just to put you at ease, maybe dermally speaking, it's going to take a lot of effort for a bunch of that tretinoin to go through the scalp and interact with the dermal papilla, whereas orally, obviously you're going to get a higher circulating blood API that can interact with the hair follicles and kind of cause that shedding issue. So my position on isotretinoin is balanced. For severe seborrheic dermatitis, very low dose isotretinoin can make mechanistic sense because it reduces sebum, follicular congestion, sebaceous gland size, and even Cutibacterium, propionobacterium pressure, but also it's going to make it less likely for the hair shedding issue. If you're a woman, be cautious. Take birth control. If you get pregnant, cease all use and go get your little guy or gal checked that's growing in your womb. And for guys, you still have to sign up for the program in the United States, the iPledge program. I guess keep doing what you're doing and keep using it, but just don't let your little kid or your pregnant wife be exposed to it. That's very important. So my thoughts before I give the protocol at the end of this video. Look, an oily scalp is pretty much just this complex ecosystem disorder where you do have sebum composition that's higher in triglycerides and cholesterol that ultimately feeds microbial overgrowth of specific microbes, being Malassezia species, Cutibacterium, Staphylococcus, and the upregulation of some microbes can also reduce other more positive microbes that would otherwise keep your scalp in a homeostatic environment. You're also going to see some immune activation and possibly some signaling from the gut, which would be related to your diet, but hormones and barrier function should also be taken into account. The Suzuki et al. Paper is the centerpiece because it shows that androgenetic alopecia scalps have altered sebum composition, which leads to higher triglycerides and palmitic acid, where more Malassezia restricta, increased Cutibacterium, and decreased Corynebacterium leads to issues that some people might call a DHT itch. This supports the idea that a balding scalp may have different fungal and bacterial environments and not just a smaller hair follicle density. Looking at Yang et al., that paper strengthens this sort of assertion because it shows that Malassezia restricta and Staphylococcus species do not just merely coexist, but they also alter each other's gene expression. So they're also showing a competitive behavior. It is that competition that, when it is disturbed, can cause overgrowth in either microbial colonies. Zhao et al., with their gut-skin axis review, adds another layer because it shows that your gut microbiome and even your diet itself can influence skin through immune regulation, microbial metabolites, and, in general, inflammatory pathways. All of this relies on metabolic signaling. So, of course, be cautious of what you eat. If you eat like shit, you're going to excrete shit. Not just out of your ass, but also out of your skin, if we're going to be honest. The Cutibacterium point is especially important here. I want to bring that up again because Cutibacterium lives deeper in the pileosebaceous unit, where oil and a lower oxygen presence create the perfect niche for it. If Corynebacterium and Cutibacterium, which are kind of battling in the sebaceous glands, if there is an upset in this competitive balance that favors Cutibacterium, you're going to see it become more dominant, and it's going to inflame the sebaceous unit of the hair follicle. We have to remember the Cutibacterium exists at a greater abundance due to its advantage by creating cutimycin, which can harm other microbial life on your skin and in your skin, but also for the fact that it can produce lipases, which can allow it to break down triglycerides and cholesterol into free fatty acids, which is essentially its food. Corynebacterium helps slow down and mitigate Cutibacterium if and only if the sebum composition doesn't heavily favor lipids that it can't break down. Because if it can't break down those lipids, there's going to be less of the Corynebacterium and more of the Cutibacterium, also known as the acnes bacterium. We can also look at MCT oil, and MCT oil itself in the C6, C8, and even C10 and C12 kind of ranges can help slow down Malassezia because it restricts its ability to break down the acids around it, the lipids around it, and essentially suffocates the Malassezia and also can mitigate Cutibacterium and other bacterium that rely on breaking down triglycerides and other parts of the sebum in order to extract fatty acids from it. The MCT oil is kind of preventing that metabolic process. And finally, like I mentioned before, isotretinoin. Isotretinoin itself, at a low dose, microdose, is going to help when it comes to a general oily kind of output from your scalp. But you should proceed with caution and be sure not to go to a higher dose or to really, give your body a break. Because if you're on microdose isotretinoin for anything longer than, I would say 6 months, you're probably going to be risking hair shedding. Even at the microdose, you're probably going to be risking hair shedding. So maybe take a week off, maybe 3 times a week. Still work with your doctor to find a sort of good protocol when it comes to that. Obviously, I'm not a doctor, but I have my own thoughts when it comes to this. So now the comprehensive protocol for dealing with an oily scalp. So disclaimer, I'm not a doctor. Go check with your doctor before you try anything. This is all based on my research of the literature, and it's mostly just my opinion. So let's get started. So step 1 would be identifying the oily scalp subtype. The first thing I would do is separate oily scalp into patterns. If the scalp is oily but not itchy, not red, and not flaky, then the main issue may simply be seborrhea or excessive oil retention. If the scalp is oily with greasy flakes, itch, redness, or irritation, then seborrheic dermatitis and Malassezia overgrowth become more likely. If the scalp is oily with bumps, pimples, pustules, crusting, tenderness, or pain, then we're probably looking at folliculitis or other sort of folliculitis-related conditions being in the picture. If the scalp is oily with burning, perifollicular scaling, shiny patches, loss of follicular openings, patchy hair loss, or pain, then I would not treat that as simply an oily scalp. You got to get your ass to the dermatologist and get an evaluation because you could be dealing with a scarring alopecia or an inflammatory scalp disorder that may be persistent. Step 2 would be to remove the obvious lipid triggers. For the first 4 to 8 weeks, I would remove the heavy scalp oils and occlusive products. This means no heavy pomades, no grease butters, no castor oil on the scalp. Coconut oil in some respects may help along with olive oil. Sometimes it may help, but I would probably revert to using a lower chain medium triglyceride. Something like C6 or C8 MCT oil, or even squalane in a minimal amount. I would not use it as a replacement or antifungal therapy if the person has active seborrheic dermatitis. I would use it as a safer vehicle choice when the scalp needs lubrication without feeding Malassezia, the same way longer chain oils might. Now, in this particular case, you may consider things like ciclopirox shampoo or ketoconazole shampoo. Ciclopirox shampoo I find to be the best at a 1% concentration. It doesn't really dry my scalp. Along with other people, they also say they like it. Ketoconazole at 1% or 2% may kind of fry your scalp. It can fry your hair, rather. So I would be kind of cautious with that. It does work, but ciclopirox tends to be better. And also there's some literature, I won't go over it because the video is already long enough, but there's some literature that shows that there's less resistance to ciclopirox in the microenvironment. You may also consider topical terbinafine or topical doxycycline as well. Topical terbinafine is a antifungal, whereas topical doxycycline is a antibacterial. Using both of these topically may potentially help and also be synergistic because they might suppress those microbes that, remember, some of those microbes can force your sebaceous glands to produce more oil, and that's through its lipase synthase machinery. Step 3 is going to be important, and this is a cleanse based on oil production. So if you're producing oil a lot, don't avoid washing your hair. It seems pretty simple, right? But you shouldn't fear shampooing. I know there's this anti-shampoo movement going around, but it's pretty important that you do have an aspect of cleaning your hair. For oily scalp, washing more often can be appropriate, and the idea that everyone should be avoiding frequent shampooing does not apply to every single scalp, because if oil is building up quickly, that oil can become the substrate for Malassezia and bacteria. I would consider using a shampoo that consists with ciclopirox, terbinafine, maybe even benzoyl peroxide. If you can get those, that would be nice. And the reason why I say that is because this is sort of a broad spectrum microbial overgrowth killer. You're treating your bacteria, you're also treating your fungal colonies. And something like salicylic acid may be included in there as well. Tea tree oil. These are also microbial regulators as well. For a very oily scalp, I would use this shampoo that I described daily or nearly daily with a conditioner of choice. For people with curlier or more coily, kinkier hair, I would still cleanse the scalp often enough to control oil, but I would protect the hair shaft with conditioner applied mainly to the hair and not just simply rubbed into the scalp. Because for those kinds of hair types, more frequent washing can cause breakage, so just make sure you're conditioning the hair properly and be gentle with it. And step 4 is pretty much like step 1 because we're adding that ciclopirox, those anti-seborrheic dermatitis sort of shampoos, the ketoconazole, all that's going to apply. What I typically do when I'm in the shower, when I apply these antifungal shampoos, is that you have to make sure you wet the scalp first. The scalp has to be wet along with the hair for about 5 minutes. Once the scalp is wet for 5 minutes, you have to put in the shampoos and kind of just massage it into your scalp. Whether it's ciclopirox, ketoconazole, benzoyl peroxide, you want to lather it into the scalp and be pretty consistent with it. And do that for around 5 minutes. So in total, between wetting your scalp for 5 minutes and washing the scalp with the shampoo for 5 minutes, and then when you're done, you just wash it all out. So that's 10 minutes, maybe 12 minutes total. For step 5, if you have scaling, you probably want to treat that. So if a person has thick, greasy, stuck-on scale and flakes, this is when the salicylic acid that I mentioned before is going to help, because it can break apart those scales, and also it can kind of create the environment where you can help the ciclopirox and other antimicrobial and antifungals, or rather antibacterials as well, come in and clear out the area. And benzoyl peroxide, which would really be for the step 6 when it comes to folliculitis. I know I mentioned it before, but you can combine benzoyl peroxide with clindamycin, whether it's a shampoo or a sort of cream. I would typically use this, and I use this myself, 2 to 4 times a week. And benzoyl peroxide is going to really reduce that bacterial burden, but also clindamycin has its own antibacterial properties as well. The two together, it's like a chef's kiss. And it can actually prevent folliculitis in many cases, so that's pretty cool. If these bumps, the folliculitis bumps, keep returning, I would probably get a sort of KOH test of my scalp. So you definitely want to go to the doctor and get a KOH test to see what kind of issues you might have. You could have, Cutibacterium driven follicular inflammation. You could have Malassezia folliculitis, which is possible. You could even have Tinea capitis, which is ringworm. a lot of inflammatory scalp diseases can look similar to the untrained eye. With that being the case, they usually require extensive diagnostic tools, which would be the KOH test. And all of this leads to step 7 when we're thinking about the biofilm nature and the dysbiosis issues of the microbial colonies. So biofilm, this sort of protective armor, is what's going to cause for these microbes to have resistance against the medicated shampoos we use or even our immune system. What could potentially help here in this case is by simply using isopropyl alcohol at a 70% concentration, because it's going to weaken that biofilm and probably kill a lot of the bacteria and the Malassezia as well. And if it doesn't, again, they're going to be weaker, so your medicated shampoos that follow will definitely destroy them. Or rather be more likely to destroy them. We can't say definite. Step 8, use diet as a sebum control and gut-skin leveler. Look, if you're eating horribly, if you're eating processed foods, sugary drinks, white bread, refined carbs, and all that stuff, if you're eating an excessive amount of these things, not just, a moderate amount, but an excessive amount of these things, you have to reduce it. Too much alcohol, you have to reduce it, right? If you have any sort of sensitivities to specific foods, you have to avoid it, because that's going to allow for your skin to have inflammatory issues which could potentially harm the skin barrier. The general point here would be to walk away from processed foods. I think between all diets, that's the most, toxic sort of aspect that would be contributing to a chronic oily skin appearance. Step 9 would be to manage your sweat, friction, and buildup. If you sweat a lot, if you work out a lot, look, wash your scalp. Even if you already washed your scalp earlier that day, wash it. Also, your pillowcase, wash it frequently. If you're wearing any hats, any sort of head covering, just wash it and switch it around frequently, cycle it around. And I would avoid anything that kind of scratches and, turns into like some kind of itchy sort of problem for your skin. I know some people are more sensitive to certain fabrics, so definitely avoid any fabric that causes irritation to you. Step 10 would be to escalate to oral antifungals only when appropriate, right? I would not just use oral antifungals just right off the bat because the scalp's oily, but that's only if other things are failing, because, that could cause some problems. Oral antifungals can put some stress on your liver, but also it can mess with your stomach and it has its own side effects, so this should be used for more extreme cases. But you might be able to microdose it, who knows? According to Malassezia et al. In the 2014 paper titled, quote, "Comparison of the efficacy of fluconazole and terbinafine in patients with moderate to severe seborrheic dermatitis," unquote, patients were treated with either terbinafine 250 milligrams daily or fluconazole 300 milligrams weekly for 4 weeks. Both drugs significantly reduced seborrheic dermatitis severity and itching, but terbinafine showed a stronger reduction in disease intensity in their analysis. Now, this is oral terbinafine. I would imagine topical terbinafine, which in the United States is over-the-counter, can also possibly be used before you commit to any sort of oral antifungals. But please go talk to a doctor. Step 11, if your sebum is getting a bit too out of control and nothing is working and it's becoming very severe and reoccurrent, then you probably have to consider something like a low-dose isotretinoin, at least for the temporary period. That can help reduce the oily nature of the scalp and can also help reduce the presence of specific overly grown microbial colonies. For step 12, maintenance is the idea once everything is controlled. I would keep, in my opinion, and this is what I typically do myself, to deal with seborrheic dermatitis, to prevent oily scalps and itching scalps, all that, I would keep ciclopirox once weekly or every 7 to 10 days if seborrheic dermatitis tends to return. I would use benzoyl peroxide once or twice weekly if folliculitis tends to reoccur. I would continue avoiding heavy scalp oil, so I would also use the MCT C6 and C8 oils or the squalane only if the scalp needs an oil-like vehicle to suppress any sort of seborrheic dermatitis. I would probably use this, and I typically use this like twice a week, but 3 times a week at most should be fine. And also, try to keep a healthy diet and lifestyle that would be realistic enough to maintain this protocol, but also to prevent seborrheic dermatitis. So that means keeping your diet in sharp order. Finally, like I said earlier in the video, if you have any sort of burning pains, pustules, and any sort of shiny patches or loss of follicular openings, any sort of perifollicular scaling, that is a sign of some more serious issues, whether it's, folliculitis decalvans, which is a scarring alopecia caused by bacteria, particularly Staphylococcus aureus, or if you have a lymphocytic sort of autoimmune scarring alopecia, that can also be sort of a red flag. But obviously, raise that to a dermatologist. But I've been yapping for an hour now, and my voice is completely shot, and I don't want to talk too much. I need to drink some water and go live my life. But with that being said, I want to introduce you guys to a website that I've been working on. It's actually a service. It's called TrichoLens. That's TrichoLens. It's a very specialized AI trichologist that can help you come to a conclusion about what's going on with your hair, and you can take that to your dermatologist to have more informed conversations. Now, at the moment of recording this video, we're having a sale for $10 a month for the basic and $20 a month for the pro. You do need to use a scalp camera. Don't worry, we have all those sources on where to get it on the website. If you go to the shop section, it'll lead you to Amazon, where you can find tools that work with the app that we made. But also, for some of the tools on our service, you can use your regular phone camera. We do have tools where you can detect sebum and other sort of scalp fungal issues by using the spot analysis tool. And yeah, that's pretty much it. Go check it out, and I hope you try it out. So I'm done rambling. I'm done yapping. Hopefully this video is helpful when it comes to treating an oily scalp. I try to give a bunch of information. All the sources and everything, timestamps will be in the description. And yeah, I'm heading out now, and I'm going to take a break from talking for the whole day. Peace out, guys. See ya.